Your bank, your food app, and Netflix probably all run on the same database. Every app you use today is powered by a database sitting quietly underneath the surface. But here's the thing, most people have no idea which ones, or why it matters. In 2026, the choice of database shapes how fast an app loads, whether it crashes under pressure, and even how much your data costs to store. The database market is enormous. Analysts estimate it was worth over $100 billion globally in 2025, and it's still growing fast. But what's really interesting is that the market isn't splitting into dozens of winners, it's actually consolidating. One technology has pulled so far ahead of the competition that engineers at wildly different companies are all landing on the same answer. So what is this dominant database? It's PostgreSQL, often just called Postgres, an open-source relational database that's been around since 1996, quietly refined for nearly 30 years. And in 2026, it has become the most used and most loved database among professional developers. Let's find out how that happened. Before we go further, let's cover the basics. A database is simply software that stores and retrieves information. When you open your banking app and check your balance, the app sends a question to a database, and the database sends back your number in milliseconds. There are two main families of databases: relational databases, which store data in neat tables like a spreadsheet, and NoSQL databases, which store data in more free-form ways. For about a decade, from around 2010 to 2020, the tech world was obsessed with NoSQL. Companies like MongoDB and Cassandra promised that traditional tables were old-fashioned. They said the future was flexible, document-based storage. Startups rushed in. The phrase, "NoSQL is the future," was everywhere. But something unexpected happened. The proof is in the developer surveys. Stack Overflow surveys tens of thousands of engineers every year. In 2023 and 2024, Postgres was ranked the single most used database by professional developers, beating MySQL, Microsoft SQL Server, MongoDB, and all the rest. It also topped the most admired list, meaning engineers who used it actually wanted to keep using it. That's a rare combination. But surveys are just opinions. Let's look at real job data. When you analyse hundreds of thousands of engineering job postings on LinkedIn and Indeed, a clear pattern emerges. PostgreSQL appears in more back-end and data engineering job listings than any other database technology. In fact, by early 2026, it outpaces MySQL by nearly 30% and MongoDB by over 70%. Employers are voting with their budgets. So what actually makes Postgres so good? Let's start with its history. Postgres was born at the University of California, Berkeley in 1986. A professor named Michael Stonebreaker led the project. The goal was to go beyond older databases like Ingres, which Stonebreaker had also worked on, and build something more powerful and more flexible. It was released as open source in 1996, and because it's open source, nobody owns it. A global community of volunteers and companies has been improving it ever since. One of Postgres' secret superpowers is that it's both a relational database and a document store. Remember how engineers loved MongoDB because it could store flexible, free-form JSON data? Postgres added native JSON support in version 9.2, and by version 9.4, it introduced the JSON-B binary format, enabling storage and querying of JSON at speeds that rivaled MongoDB. So suddenly, engineers had one database that could do both jobs. That's a huge deal. Postgres also handles something that trips up almost every other database: transactions. Imagine you're transferring money between two bank accounts. The money must leave one account and arrive in the other, both at the same moment. If the system crashes in between, you can't lose the money or duplicate it. Postgres uses something called ACID compliance to guarantee exactly this. ACID stands for atomicity, consistency, isolation, and durability. It's the gold standard for data safety. Now let's look at real companies. Let's start with financial apps. Stripe, the payment infrastructure used by millions of businesses, uses Postgres as a core component of its data stack. So does Brex, the corporate card startup. When you tap your card to buy a coffee, there's a reasonable chance that transaction flows through Postgres. The reason is simple. Financial data demands strict guarantees, and Postgres is the best at providing them. What about food delivery? Uber Eats, DoorDash, and Instacart all rely on PostgreSQL for significant portions of their data infrastructure. The engineering blog teardowns are fascinating. Uber, for example, famously moved away from Postgres in 2016, but they came back. By 2023, Uber's internal tools and many of their microservices were running on Postgres again, this time through managed cloud versions that solved the scaling problems they'd encountered years earlier. Now what about streaming? Netflix is a legendary case study. Netflix runs one of the most complex data environments on the planet, serving over 260 million subscribers. While Netflix uses many databases for different purposes, PostgreSQL underpins key parts of their metadata, user preferences, and content catalogs. The engineering team even published blog posts about their Postgres optimization techniques. When Netflix engineers write about Postgres, the industry listens. Let's talk about the cloud angle, because this is where the Postgres story truly explodes. Every major cloud provider now offers a managed Postgres service. Amazon offers Amazon RDS for Postgres and Amazon Aurora. Google Cloud offers Cloud SQL and AlloyDB. Microsoft Azure offers Azure Database for Postgres. These are hosted, fully automated Postgres instances. You don't have to manage the hardware, the backups, or the security patches. The cloud made Postgres accessible to everyone. One of the most surprising developments has been Postgres absorbing use cases that used to belong to completely different database categories. Need vector search for AI applications? Postgres has pgvector. Need time series data for sensor readings? There's an extension for that. Need full text search? Built in. Need geospatial data, like mapping apps? PostGIS has been doing that for 20 years. Postgres has quietly become the Swiss Army knife of databases. The AI wave of the last 2 years has supercharged Postgres even further. When OpenAI, Anthropic, and other AI companies build applications that need to store and search through embeddings, which are mathematical representations of words and images, they reach for pgvector, a Postgres extension. This has made Postgres the default database for AI startups in 2025 and 2026. The technology that was old enough to vote is now at the bleeding edge of artificial intelligence. Let's look at how a typical production app actually flows data into Postgres. When you order food on an app, here's what happens, step by step. Your phone sends the order to a server. The server writes the order into a Postgres table. Postgres confirms the write. That's the ACID guarantee. The restaurant and driver information are read back from Postgres in milliseconds. The whole cycle completes before you can blink, and Postgres sits at the center of every step. Now, Postgres isn't perfect for every single use case. There are things other databases genuinely do better. Redis is faster for caching because it stores everything in memory. Cassandra is better for writing enormous volumes of data across many servers simultaneously. MongoDB still has a strong foothold in teams that prefer document-only workflows. The reality of big production stacks is that Postgres sits at the core, but it's often surrounded by specialist tools handling specific tasks. One reason Postgres has won so decisively is economics. The biggest alternative for large enterprises used to be Oracle Database. Oracle is incredibly powerful, but a license can cost tens of thousands, even hundreds of thousands of dollars per year. IBM's database products are similarly priced. Postgres is free, forever. When a startup or a bank can save $1 million a year on database licensing and get equivalent or better performance, the decision practically makes itself. Another underrated factor is the ecosystem. Postgres works with virtually every programming language that exists. Python, JavaScript, Go, Java, Ruby, PHP. They all have mature, well-maintained Postgres connectors. Every popular web framework has a first-class Postgres integration. Django, Ruby on Rails, Laravel, they all point to Postgres as their recommended database. When the entire ecosystem is pulling in the same direction, network effects take over and the lead compounds year after year. Let's zoom out and look at the trend in raw numbers. The DB Engine's ranking, which scores databases based on search volume, job mentions, and discussion activity, has tracked Postgres rising steadily for over a decade. It has consistently closed the gap on rivals like MySQL and Microsoft SQL Server. By 2022, it was pulling away from the pack in terms of growth rate. In 2026, its score is roughly double what it was in 2018. No other relational database has grown at anywhere near this pace. What does all of this mean for the future of data? A new wave of Postgres-compatible databases has emerged, built specifically to handle massive scale. Neon is a serverless Postgres provider. CockroachDB is globally distributed and speaks the Postgres language. PlanetScale, originally MySQL-based, started adding Postgres compatibility. The entire industry is converging on Postgres as the common language of data. Just like English became the lingua franca of international business, Postgres is becoming the lingua franca of databases. Here's one last way to feel the scale of this. Right now, as you watch this video, there are an estimated 800,000 to 1 million active Postgres instances running in production environments around the world. Those databases are collectively handling billions of queries every single day. Every flight you book, every rideshare you request, every grocery order you place, there is a very high chance a Postgres database is involved somewhere in that chain. The story of Postgres is really a story about how good software, freely shared, can quietly reshape an entire industry. It wasn't backed by $1 trillion company. It wasn't marketed with a massive campaign. It just kept getting better, year after year, because thousands of engineers around the world chose to contribute to something bigger than any one company. The next time you open your banking app, order your dinner, or press play on a movie, take a moment to appreciate the invisible infrastructure making it all possible. Most of it runs on a free, open-source database that started in a university lab in Berkeley nearly 40 years ago.